Our last day of pre-cal review. So this is our day 3. Just a reminder that after this lesson, there's going to be a review lesson, and then it's going to be the review test. Okay, so the test is on anything that we've covered here. And I'm also going to post the online homework to help you study for your test after this video. So for day 3, we're going to look more into things that we didn't really cover that much in pre-cal, but it's kind of implied that you would know how to do it. So I feel like question 1 and question 2 should be fine, and in question 3, but in question 4, we kind of want to prepare you for that calculus mentality. And we don't usually do this in pre-cal, at least not a lot of it. And you might have seen it before, but it might be a long time ago. We're going to use a lot of these slopes because eventually we're going to calculate derivatives, which are slopes. And we're going to look at those slopes passing certain points. And we want to find the equation of a line for that. So remember, the equation of a line, of a linear line, is going to be y equals mx plus b. So I'm just going to answer maybe one of these. I'll maybe do 4c. So if we want to pass through points 5, 2 and negative 3, 9, first of all, we need to find the slope. We need an m. So that's what we're going to find first. And m would be y2 minus y1 over x2 minus x1. So that's 9 minus 2, and then minus 3 minus 5. So that's going to be 7 over negative 8 as our slope. Now we can just pick any point for your x and y to plug it in to find our b. Okay, so then let's just use 5, 2. And our x was 5. So we're going to solve for b. So this would be negative 35 over 8 plus b. I want to move that 35 over 8 to the other side. So that's 2 plus 35 over 8 is equal to b. And then I want to simplify that fraction. So I need a common denominator. Multiply this 2 by 8 and the denominator by 8. So you get 16 over 8 plus 35 over 8. And this is going to be 51 over 8. So that's our b. So in our final format, it'll be y is equal to negative 7 over 8 x plus 51 over 8. You could also do something else, which is probably going to be less work. You also use this format over here, which is y2 minus y1 is equal to m x2 minus x1. This is also another way of writing an equation of a formula. We're used to seeing this from pre-cal in our earlier days. This is what we will tend to use more in calculus. It does the same sort of thing. So all you have to do is find m, the slope, and you can plug in any point in here. So your y1 and x1. So let's choose 5, 2 again. So that's y minus 2. Your slope was negative 7 over 8 times x minus 5. So this would be our final answer. We don't need to simplify. And if we do simplify, we're just going to get back this anyway. So this is in their expanded form. And this one is not. But it's fine. They're still equivalent to each other. Okay, so for graphing functions, maybe it's just better to draw all of your basic graphs on the side. And then these are just different transformations of those basic graphs. So you can see here, you need to complete the square first in order for you to graph this parabola. And remember, a parabola has a shape that looks like this. Okay, so your vertex here is at 0, 0. For B, your normal graph would look like y equals 1 over x. You have an asymptote along x equals 0 and along y equals 0. And you get 2 arms in quadrant 1 and then the other one's in quadrant 3. And then your radical root x starts at 0, 0 and then moves on. That. There are also other graphs that you could need to know how to draw as well. Maybe y equals x cubed. Just looks something like this. And those are the main ones. Maybe you can see an absolute value one as well. Looks like so, like a V. So I would definitely know these ones for calculus for sure. And these are just transformations on your basic graphs. Remember, to find zeros, you're going to need synthetic division for that question. Factor it fully, and then those will give you your zeros. Now I'm going to look at piecewise functions. Again, piecewise functions aren't that common in pre-cal, but you'll see this a lot in calculus. So I'm going to do an example of a piecewise function to draw. Let's just say this is going from x is smaller equal to 2. And then the other side of our graph is an absolute value function where x is greater than 2. So to draw your piecewise function, you can just think of it at one piece at a time. The part where our graph tends to break off is over here at x equals 2. Now I'm just going to draw my y equals negative x graph, but stop right when we hit x equals 2. So I have a negative slope, and my slope is 1. So I have a point at 0, 0, negative 1, 1, and so on. And once we get here, it stops. But it's connected. And it's including 2, so make sure we close that hole. And I'll draw an arrow because x can be smaller or equal to 2, and it can go on forever in the negative infinity side. Now looking at the other side, we get an absolute value starting at x is equal to 2, but we don't touch it because it's not equal to. So absolute value kind of look like this, keeps going on, like a V. So at 2 is going to be at y equals 2 as well. Then when it's at 3, it's going to go at 3, 3, and so on. Okay, and make sure you have an open circle here because you're not including 2. So that is the graph for this y function. Now for question 10, we don't have to graph it, but you can just plug in the values. Just be careful of what that number is because we have to make sure it fits into the domain. So if it's -1, -1 would belong over here because -1 is included in this domain. So you're going to plug -1 in this function, only this function. If it's 1, then you're going to plug it into this function here because x is greater or equal to 1. So this includes 1 in the domain. So you're going to plug 1 into this part of the function only. Okay. Then lastly, the last question, it's f of g type of question. So remember when you have f of g, this could also look like this, f of g of x. And you're going to plug that into each other. So g would go into here. And then you're going to plug x cubed minus 1 into your f of x function. Then afterwards you can plug in 1 right away and also -3 right away. So this one's a bit shorter than last time. That's all the different questions that we're going to really focus on this section of our pre-cal review. I have posted your solutions to all the pre-cal reviews from day 1, 2, and 3 on the OneNote, so please take a look at them. And if you have any questions, please send me an email. I'll try to answer it, or you could even email me and direct me back to the OneNote because you've written a question on there that I can answer. So just please keep in contact with me about stuff like that. And if you need extra practice, you can always go to this website down here. They have a ton of videos and worksheets that you can do that are very similar to these questions that you've been doing here. Okay, so again, check your online homework because I'll be posting some questions for you to review for your test on there. And then your test is in two days from now.